So, welcome to another Microservices Meetup. Glad that so many of you showed up. Who's here for the first time at the Microservices Meetup? No, you're not. No cheating allowed. So very few people this time. So a lot of people regularly go to the meetup, hopefully. We are back to Einstein Kultur this time, which also means that once again, the nice folks from AutoScout24 are sponsoring the meetup, and this has a good reason. First of all, it's a good meetup, and we are talking about Majestic Modular Monoliths, and AutoScout had one of those monoliths, which is currently carved up into microservices.
Was it majestic?
Of course, it was the most majestic of all monoliths you could think of, especially if you look at the database. The modular is doubtful, but the majestic part we managed to put in place. So, thanks to AutoScout for sponsoring the pizza, the beer, and the venue. And they are still hiring. So, if you're interested in carving up the monoliths even further into microservices, please go there and help those nice folks. And I'm happy to have Axel the second time now. He's one of the very few speakers at the Microservices Meetup who actually is allowed to appear a second time. And I'm totally looking forward to this talk because I don't actually know what he's going to talk about, except what the title gives away. So I'm looking forward and I'm really interested. And you will introduce yourself, hopefully. Yes. I'm very happy that he's here. Give him a warm welcome.
So first of all, from my side also, thank you very, very much for braving all the ice-cold temperatures and slippery sidewalks to come here after a long day at work. Truly appreciate it. Just out of curiosity for me, who attended my previous talk here at the Microservices Meetup? Hey, very good, very good. Thank you very much, guys, for coming back. So today we're, as Christian said, we're going to talk about Majestic Modular Monoliths. So who's going to talk about that? That's me, Axel. So who am I? I'm originally from Belgium. I moved here about 12 years ago now. I've been in IT all this time for about 20 years now, more or less. I've been mostly active on the JVM side of things and on the DevOps intersection between dev and operations part of projects. I'm an Oracle Java champion. I run a company called BoxFuse. We have two products on the market, BoxFuse and Flyway, so that's basically what keeps me busy these days. So we're going to be going for about, I estimate, just over 50 minutes, maybe, something like that. And we had a bit of a late start, so if you do have any questions, please hold on to them till the end. We'll have plenty of time afterwards and plenty of beer to go in detail about any kind of subject you want. And then if people are in a hurry, then we don't hold them back a lot longer. So, if this is a bit of a special place because I feel I'm talking about my monoliths in the church of microservices. It feels a bit like a heretic's job to be able to do that. And in fact, this is really not something new. So this is a picture of Pope Sixtus V from the 16th century, and in fact, in 1587, he created this job very specifically. He created the job of the Advocatus Diaboli, which is really the devil's advocate, which was really a way to be able to appeal to a canonization decision of the Pope, to be able to provide counter-arguments that may not have been obvious before. And so this is a little bit also the aim of this talk here today. It is to, in a sense, generate an opposition to the dogma that has been associated with microservices for the past few years, and hopefully provide some interesting food for thought or some ideas that you can take home with you and reflect upon. So if we look at our little life cycle of actually producing code when it starts in our head, and then we type some code in some IDE, and we'll compile it down to some machine code, and we'll execute it on a CPU. This is a bit the standard flow that we have to actually be able to breathe some life into a program. And the thing is, when you get started, it's all nice and easy, but as the program grows, at some point, one of those parts of the puzzle is going to be the bottleneck. And it is very easy to see which bottleneck we're going to hit first. It's basically us, the human side, is going to have the first, we're going to be the first to have trouble to make sense of an arbitrary large amount of code. Why is that? Because in a sense, a lot of our job is really centered around not writing code, but really understanding and reading code. Yeah, I would almost venture here that we have a 95-to-5 read-write ratio when it comes to larger projects where you really want to understand what is going on, and once you're sure of where you're going to make your change, and there is a little bit of typing involved, but the vast majority of the time is actually spent on understanding instead of producing. And so we should clearly optimize for that part when we have the choice, because that's where we can really make the biggest gains. So how do we do that? Well, the first step we can do is add structure to our code, so that we then are able to gradually make out the different parts and the high-level constructs that we have. We can raise the level of abstraction. I think today there is nobody anymore who truly understands everything that happens between pressing a key on a keyboard and actually having the letter appear on the screen. When you kind of peel down the layers of the onion, there is just too much complexity, so we raise the abstraction to be able to understand it and to really be able to reduce the load on our own brains, because this is really at the end the thing that's holding us back. Where it's all about seeing the forest through the trees. And how do we do this? We create structure by adding methods to our code, and then we group those into classes, and we'll group the classes into packages, and we'll then group packages into modules, and we'll group modules into applications. And this is how we gradually introduce these elements of structure to be able to understand what our application is doing. And this is basically the definition of architecture. This is really the interactions and the relationships between those elements that we've introduced. Now, if you look at architecture styles, I think these days a lot falls into one of these two categories, either monoliths or microservices. If you kind of go by a lot that has been said on the agenda of conferences the last few years, a different way to present these two choices would be something like this, where the monolith is traditionally doesn't have a very good reputation, let's say, and microservices are really hip and cool because, well, after all the cool guys are doing it, so we should be like that as well. So the companies I've listed here, they're really at the forefront of all that, whether it's Amazon, Google, Netflix, or Twitter. A lot of the innovation, a lot of the open source projects, a lot of the ideas are being driven from inside those companies. But what kind of companies are they really? If you kind of look at these guys, and you look at the company you work for, how similar are they? How similar is your company to one of these technological giants which we look up to all the time for the stuff they do in the industry? If you kind of look at the dimensions that they have, I think it's really interesting. There was this tweet a while ago, which I really liked. If you fetishize and cargo cult the infrastructure required by companies with literally 10,000 times your traffic, you will not have fun. And I think there is certainly a lot of that involved. I've spoken at QCon London, and they always have this track. It's actually the first track on their program. It's called Architectures You've Always Wondered About. And it's basically also, you'll have eBay or Twitter or Google presenting some of the challenges they faced when they developed some of the products that they've had out there. And I thought to Floyd, the organizer of QCon, I told him, you've really got the wrong name for your track here, because when you kind of think about it, it's really the porn track, because it all looks fabulous and really exciting, and then you go home and it's completely different, and there's none of that. So really, we've got a bit of a misnomer there, and I think this is quite. I think it's quite normal. We envy the solutions of the big guys because we envy their reputation and what they're actually doing out there, but it may not always be the right solution for us. And to just kind of put things into perspective a bit more, I went today on the jobs website for Amazon. So this screenshot I took early afternoon today of www.amazon.jobs, and what do we have here? If we kind of look a bit more in detail, we see that they've got 5,678 open positions. You're going to tell me, well, you know, Axel, they all work for about €1.50 an hour in a warehouse and they're being exploited, and that's not really the kind of jobs that we have. Well, wait a second. We're going to scroll down a little bit on this page. And what do we have? Let's have a look. Business category. Oh, this is only for AWS. So AWS alone has 5,678 open positions today. But you can say, well, they've got a big sales team and they've got lots of people around it, so they're really technical. Well, let's have a look. Let's dig in. And we can see software development, software architects, operations, IT, support engineer. That alone is 3,297 open positions today. That's what's open. That's not the total staff. Now compare this to the size of your company and how many jobs you currently have open, just to kind of see the kind of problems that these guys are attempting to solve and the amount of resources that they have at their disposal to solve them and how they compare to your company. If you have the same, good for you, but chances are that you'll be an order of magnitude or 2 or 3 below what these guys have, and so the solutions that they are able to produce may not be the most economical or the most sensible ones for your context. Now, monolith microservices, as we saw before, they're a bit loaded terms by now in terms of appreciation and how people view them. So I actually really like the way David Hansen had rephrased it a couple of years ago in his RailsConf keynote, where he basically said, you know, it's a bit unfair, so let's call them really what they are, where we're talking about integrated systems and distributed systems. Because this is really what a monolith is at the end, or what a microservice architecture is on the other. Distributed systems. We've heard that before, I believe, so let's see what Martin Fowler has to say about that. Well, his first law of distributed object design is don't distribute your object, so maybe we have something similar for systems as well. Let's have a look. How do monoliths and microservices compare? First of all, on the monolith side, we have usually a single artifact that we'll deploy, and then on the microservices side, we'll usually have an artifact per service, probably, that we're going to be rolling out. It also means on the monolith side, I think it's part of the main drivers for the microservices adoption, that we've got a strong entanglement risk of the code base, versus on the microservices side there, I think a lot of the individual services are much closer to greenfield and have an overall much lower level of complexity, so they're more focused and they're more clear in what they do, so that's actually quite a nice thing. On the other hand, when you actually want to interact between those, on the monolith side, it's a nice, reliable method call in memory. The microservices side, well, you've got your network in between, and all kinds of things can happen on the network. Where on the monolith, everything's always available, and you know you can just interact with it directly. On the microservices side, well, all of a sudden you can make sure you know where your stuff is, and when things get deployed, so you need some kind of service discovery to help you there, and you'll probably need some kind of internal load balancing, so that basically you can then balance the load across the different instances of an individual service. If that service isn't available, you'll need something like a circuit breaker to kind of prevent cascading failures and make sure that you're actually able to survive that. So there's a few things that must be put in place to make that work. On the monolith side, we've got great ID support. If you're not happy with some kind of method, you right-click, you rename it, all the references are renamed, done. If a method isn't being used anymore, it'll be grayed out and you just delete it and you're done. Much more difficult on the microservices side because all of a sudden it's much harder to track who's actually using what and how, what is the impact on being able to change that, which teams from the clients of that service actually have time or capacity available to be able to update their interfaces in the next few months so that you can actually have a smooth evolution and decommission the things you're not fully happy about. This is something that needs great care when you have to evolve that. On the monolith, if you want to scale it, you don't really have a lot of choices. It's either you kind of scale it all up as one thing or you scale it back down, but you can't really turn to many individual knobs versus on the microservices side there you can actually make a small service with lots of demand, provision it with lots of capacity and something that doesn't have a lot of load, you can just leave it small and you can scale them individually so you can have a lot of possibilities there that you don't necessarily have on the monolith side. The monolith will typically have one database. I think Christian mentioned how wonderful these databases can be there, and the microservices there, it's basically each individual service now has the choice of which kind of persistence it will use, what kind of technology, what kind of makes sense there. This has advantages and disadvantages, of course, because the more different technologies you kind of bring into your overall system, your organization, it also means you need to master more tools, you need to develop the expertise on the operations side to be able to truly understand how they behave under load and under failure scenarios. So this is something that isn't free, but it does open possibilities. Now a very nice thing, if you have one database, is transactions. Is actually knowing it's all been written in one go or it isn't there. Versus on the other side, eventually consistency basically means that you have to re-implement a lot of the logic that the database has given you for free, once again yourself in code. So this is a lot of burden that you need to take up on yourself to kind of ensure that things are kind of working well and that you have some kind of state that makes sense there. Monoliths, by definition, you're pretty much restricted to one platform where you're gonna deploy a platform here. I mean something like the JVM or .NET or something like that. Versus on the microservices side, you can go wild. You can do certain parts if they're more suited for it in Node, and then you can have some other parts on the JVM and parts in Go, and they have some nice HTTP interface, for example, to interact with each other in there. You've got a wide array of choices. Another risk of the monolith side is basically version management for your dependencies and for your libraries, because it's all kind of deployed together. So it means that you kind of have to watch out for conflicts and what this will actually mean at runtime if you pull in two different libraries that each depend on conflicting versions maybe of a third library. How does this work? Versus on the microservices side, you get nice isolation. It doesn't matter, you can use vastly different versions of the same library, or as we mentioned before, vastly different technology. So there, this is really a very, very nice advantage of microservices there. So if we kind of look at this picture, we kind of see that there is really, it's not really clear cut which is better or which is worse. There's advantages on one side, there's advantages on the other. It's kind of, it depends, I would say. If we were to simplify this, or there's one last aspect that is very nice with the microservices, and that's division of labor. That you're able, through these small individual services, to kind of map them to team boundaries within your organization, for example, so that you're able then to be able to divide work amongst a lot of people, versus on the monolith, you have a higher risk of stepping on each other's toes and kind of getting in the way of each other. And so this is actually a very nice thing that microservices have to offer. Now, a small disclaimer I forgot to add in the beginning. As you heard in the terminology, I'm using like jar, hell here and a few other things. So my background is the JVM, as I mentioned. So a lot of the things we're discussing today are universally applicable. If the JVM is not your platform of choice, please do a quick translate in your head of the equivalent concept for your platform. They're easily transportable across any modern platform these days. So if we were to kind of recap these things, a monolith is really great for small organizations where you're kind of developing simple systems, simple applications, and you don't need all that complexity on board. It is actually more of a problem than an enabler. Versus the microservices, if you've got a large organization, you're able to divide the labor, you've got a nice way to be able to scale your load individual services. There are lots of possibilities that come there at a very at a certain cost as well in terms of operability and runtime complexity that you need to manage there. And so the big question is really, is there room for something in the middle? Does it have to be this binary? Or could we come up with some kind of possibility or some kind of middle ground that would combine some of the advantages of both and provide a good solution for the medium-sized organizations and the medium-sized complexity of applications? So yes, there is. We have a fantastic solution for that. It's called the distributed monoliths. No, just kidding. Don't try this at home. It's, this is a very bad decision. Instead, we do have monoliths and microservices, and we have in the middle what I like to call a modular monolith. But as we'll see, it actually offers a lot of benefits for a lot of companies. So I would even dare to call it a Majestic Modular Monolith, and so this is what we're going to explore today. Now monoliths, we already mentioned, they have a bit of a bad rap very often, talking about monoliths, and if you hear people talking about them, they'll kind of describe the structure of the monolith as something like this, but it's, truth of the matter, it's not really fair, because if you kind of dive down into most monoliths, you'll actually be much closer to a structure like this, where there is some kind of structure in there that you can recognize. It's not total chaos, it's not perfect, but there is at least some kind of things that you can recognize there. And typically, there will be at least some form of a layered architecture in place, where we've got the classics with controllers and services and repositories accessing some kind of database. And of course, we can only call down here, then we'll have some kind of model that all of these are going to be referring to. And this is really a big classic. In fact, it's so popular that it is part of the standard scaffolding of a lot of frameworks that generate actually these things for you. These are just the ones on the JVM, but it's exactly the same for the non-JVM frameworks. So this is really a very, very standard division of, or a structure of the applications. Now, if you have different business areas in your application, if you have, for example, the customer management and invoicing and payments, you'll have kind of the same kind of structure where it kind of trickles down and you call down those layers. Unfortunately, it's never just as clean as this. So after a while, you can start to realize that, well, if I write my invoices, I will need some information there for payment. I need some information over there, and I need to get my head around that. And how do I structure this? Exactly what works there? It kind of gets messy and complicated real fast, and it's something that's unsustainable as you grow. So a nice source for inspiration on solving these things is 13 years old, or no, 15 years old. This year already, you wouldn't believe it, but the domain-driven design book by Eric Evans from 2003 was actually right on the money for a whole bunch of ideas and thinking. It was written in a different era, of course, and when you kind of read it today, you kind of read things like XML is this emerging technology that was just arriving on the market, so you kind of have to read it with a bit of a historical perspective, but still it carries a lot of very good ideas. And so the first step, if you were to adopt the ideas of BDD, today in an architecture like this would be to start recognizing that what you have here are really three major aggregates in this case here, where you would have the customer aggregate, the invoice, and the payment aggregate. Just out of curiosity, who's read the domain-driven design book, or who's familiar with that? Okay, very good. So we got a good 50% more or less. If you haven't, the original is a bit dense, it's quite big. There's a summary that Eric Evans brought out, I think two or 3 years ago now, which is much easier to distill. There's also plenty of resources online, but I highly recommend you to invest the time to kind of look into these concepts and see whether they make sense for you or not. So in this case here, our aggregates, we would probably see our customer, our invoice, and our payment as the aggregate roots, as the entities from which we'll then have other parts deriving out from the invoice. We'll then probably have some line items in there with quantities that we'll need to store and manage. And for the payment side as well, we'll have some card data and other things that need to be in there. Same for the customer. So this is a bit how this would look at a high level in DD. Quite important as well, if we're going to have dependencies between these different bits, we want to have them in an acyclic directed graph, so that we basically make sure that there are no cycles in this graph, and we want to do it in such a way that we actually manage the direction of the relationship, so that we have stable concepts at the bottom and that we have unstable concepts at the top. So that in this case here, for example, you can, customer is really something that doesn't change very much. It's central to our application, and if we modify it, it actually affects everything above it, versus on the other hand, if we change payment providers, let's say from Stripe to Braintree, and we kind of do something there, it has no impact on the customer below. So this is something that you need to look for your individual business, what makes sense and how stable these concepts are. But this is really what should be the driver when looking at the direction of relationships between major parts of your overall application. Now when it comes to really looking for these parts and defining the boundaries and the structure there's a few areas or a few guidelines that can help you. The first one is really to kind of look for highly cohesive blocks. So that the first, like in the example before, if you can isolate all the payment stuff, or you can isolate all the invoicing stuff, those are nice things that you can kind of carve out and have on their own. What you also want is to have low coupling to other modules, so that you can have some kind of encapsulation, you can kind of reduce the impact to the outside world. And when you do actually have the outside world that needs to call you, that you need to expose some things, then try to produce a small, well-defined and stable API. Because if you then modify this API, this will start generating a lot of efforts in other modules that they'll need to adapt to your changes in the API. In terms of DDD, it means that for the API, you will only want to expose things that are related to the aggregate root. Other entities and the implementation is something that you'll want to keep strictly private and not accessible from the other modules. This is quite an important thing, because through this encapsulation you can actually make it much easier to reason about the overall system. All of a sudden the details there is something that is something that you can modify freely without impacting anybody else. All the clients to that don't need to know about it, they only need to care about the API. So it's quite important to have a clear separation there, a clear boundary. And of course, when you do have a dependency between modules, you make sure that you only depend on the API of another module and not their implementation. So basically it kind of looks like this, where both APIs and implementations can depend on other APIs, but never on other implementations directly. Now, when it comes to code isolation, we actually have a whole bandwidth of options at our disposal. So the first one here is to just locate the code in a separate package. If you have a separate set of functionality, place it in its own package. It can still be built in the same jar, and it will have the same version as the rest of the application. It's deployed with the rest of the application, but you get a little bit separated. It doesn't give you strong guarantees into who's allowed to call what and in which order the dependencies are, but at least you get some kind of separation. The next level of separation would be a separate module, here Maven, so it's basically for your build tool, a module that you would build separately and would produce a separate artifact. This would still be versioned along with the rest of your application, and it would be deployed along with the rest of the application. If somehow you hit the limits of that, the next step would be to have something in a separate repository. So this would produce a different artifact, probably with its own version, and it would be deployed in the same application. So this is typically things that you would then factor out as some kind of library that you would reuse, for example. And then finally, you have the external service, where you actually don't deploy as part of the same application anymore, but it's something you deploy separately, and then you'll have some kind of interface to interact with it. And if we were to draw a boundary now between what is actually a microservices territory and what is monolith territory, it actually falls quite far to the right. We do have, on the monolith side, actually a lot of options at our disposal before we actually need to go onto that distributed deployment. And so this is really a lot of interesting things that can be considered there. When you're not happy with having everything co-located, you can actually have these two possibilities there for you and the separate module for your visit system, the kind of library. This allows you to do things like actually restricting at compile time the visibility of certain classes within your system. So this is already very powerful, because you get an immediate hint from the compiler that something won't compile if you're not allowed to actually use it. The build tool will also enforce that acyclic graph between the different modules, so that's actually quite a powerful thing as well. On the JVM side, but most tools support that as well. There's also a possibility to kind of shorten the build and test cycles by only rebuilding the things that need rebuilding. And you've got also good help from tooling to kind of be able to see the forest through the trees and generate nice overview diagrams where you get a nice high-level view of the system and the individual modules that compose it. So one of the dangers that we discussed with this is basically the jarhead or conflicting versions of a library that is being used here. So in this case here, we've got our application that's depending on some of our code and a third-party library, and both of these depend on conflicting versions of another transitive dependency there. So the first thing you can really do to reduce this problem is to really think carefully about dependencies, because this is, I'm not talking going crazy like the whole left bad story on the Node.js side of things, but still when you do need only, let's say, a few lines of code from one method from a specific library that's been licensed as Apache 2 or BSD, do you really want to pull in the whole library, or can you just copy that code inside your application and avoid pulling in the rest to kind of eliminate those problems in the first place? Again, it's a trade-off, but it's something that should be actively thought about when the decision's being made. Also, in terms of libraries that you consume, there's vastly different layers out there. You've got libraries that will pull in a whole set of other libraries where there's basically no end in sight about what's being pulled in when you pull in that one dependency, versus others are nice and clean, zero dependency, and those are really much better candidates to include in your application, because the effects are much more controlled of what you actually bring on board. If you can, try to use some kind of automated help to ensure that you actually use the same version of all those dependencies and transitive dependencies. And if there is no way to avoid it, then try to shade or render that dependency under its own package. So basically this means kind of copying the existing code but in a different namespace and including it there to avoid the runtime conflict. Now, how do some of these things work on the JVM side of things? If you want to enforce dependency conversion, there's a nice plugin for that, for example, from Maven that you activate, and it will kind of fail the build if you can't have this situation where you're depending in various modules on different versions of a specific library. So this is something that's highly recommended for any kind of project that has more than one module. It just kind of helps to keep things clean. Again, on the JVM, if you're working with a modern JVM, Java 9 now has, if you've already made the move to modules, the possibility to explicitly declare what kind of things you're dependent on, what kind of things you wish to expose to the outside world, so that those things are then nicely hidden, or the things that you don't want to have exposed are then nicely hidden from the outside world as well. It's also possible with Java 8 with a library called code assert. It's, they've got a small internal DSL that they offer where you can actually declare these are my different packages. They've got some kind of camel case notation for the packages, and you can define rules, like in this case here, that this package may use this other package, and then you can enforce those things. If you have an illegal relationship there, again, it will fail the unit test during your build. And so this is actually quite a nice thing if you're not on Java 9 yet, but on JVM to kind of enforce these things. Now, databases. It's all nice and easy if you kind of ignore that part, but this is where it kind of gets hairy. If you, I put in relational databases here because it's by far the most widely used, but certainly amongst the monoliths out there, let's say. So this is what I'm going to be focusing on. So if the application is using a relational database, it's not all bad. It comes with a couple of very powerful advantages. So the first one we already talked about, referential integrity versus eventual consistency, to be able to make sure that the data that's in there actually makes sense and that you don't have dangling things somewhere, but it's actually nice and coherent. This is actually quite strong, and of course that's being enforced when you do updates as part of atomic transactions. So these are some very, very nice things that you really don't want to give up. Now, if we look at our modular monolith accessing the database, what the first rule is really that each module that you've carved out there is only ever allowed to access its own table. So when you have a set of entities that belong to a module, only those tables and the database objects that are related to that can be accessed from that module. It also means that basically you end up with something like this, where you have kind of a direct relationship between what you have on the code and what will end up in the database. So no sharing whatsoever. And the hardest part here to get used to in the beginning is really that no joins also, because what you want to have is kind of the possibility. If you looked at our little spectrum of possibilities for isolating code, where we kind of move from left to right with stronger isolation, and at the end the final step of the isolation is to have a separate service, you want to be able to make that step if the business case is good for it. So you want to be able to carve out a piece of your database and a piece of your code and deploy that separately. If you start doing joins all over the place between these, it becomes almost impossible to do that later. So you have to have strict separation there between the objects of the different modules and never go across modules. So the only thing that you can really refer to across modules like that would be the IDs of the aggregate roots of the individual modules, so that once you have those IDs, you actually still are able to maintain referential integrity. You can still have clean transactions, and if you then choose to carve out a module into its separate service, you simply break the referential integrity between those two, and you remove the foreign key relationship, and then you're able to carve it out, and there is no bigger issue there. Of course, you then have things like eventual consistency and other things that you need to manage, but there is no huge problem that needs solving there. So in terms of being able to kind of have a nice isolation of the objects that belong to a module, the databases actually offer us a fantastic solution as well, and that's a schema. So you can define, for example, an individual schema per module and have those tables there, and then you don't do any joins across schemas, and then you're able to kind of cut out what you want to move to a service later if that is what you want to do. So this is really kind of the image you should be aiming for when you're designing your applications there. So again, data isolation, just like we had for the code, we have a whole range of options at our disposal. Let's see what we have. So the first thing is really, if you have data from different modules, you don't save it all in the same table. You have separate tables available within the same schema, same database, same database product or relational database management system in this case. The next option up, as we just discussed, you actually move these things in a separate schema. Each module owns a schema, and the objects in there, no joins across those, still within the same database, so you still benefit from referential integrity and all the transactions and all the advantages associated with that, and you're running on the same technology. If that's for some reason not enough, for example, one of those modules is really generating a disproportionate amount of load on the database server that's slowing everything else down, then you do have the option to kind of move this to a different database somewhere, so you kind of give up referential integrity and transaction, but you still have the same technology that you need to master. You don't need to learn a new technology there. And finally, if that doesn't do the job anymore, if you really see that, for example, relational simply isn't the right model for this, that you need to move to graph or to document or to whatever other technology that would be better suited for that module or service, then you can always kind of go all the way and adopt a separate technology for that. So these are really, again, a spectrum of choices that you have at your disposal. It's not black and white. You actually can choose where you are along those lines and see what makes sense for your project, for the size that you have, for the complexity needs that you need to address. If you were to use a database migration tool or a tool like Flyway, in this case here you would have these first two choices would probably mean, because you still have referential integrity, that you would have a single table to manage the evolution of your database. Once you go beyond that, then you'll probably want to have a separate one per module, or if you move to a different technology, then this doesn't apply anymore. But for those, since you still have the possibility to have those dependencies on IDs from different aggregate roots, this is something that makes sense there at that point. Now, big argument for microservices, scaling. And this is really something that's being put forward a lot. So let's have a look what kind of possibilities we have. So I put up AWS here, but the same applies to a lot of the other cloud vendors or even to your own infrastructure. So what kind of range of machines have we got at our disposal to be able to scale a monolith? On the low end, on AWS, this would be something called a T2 Nano. It costs about ½ cent per hour. It has one virtual CPU and ½ gig of RAM. And then you can basically walk through a whole series of choices. You have lots and lots of intermediate possibilities until you get to the high end. And this is an X1E32X large. There you have 128 vCPUs and 3,904 gigabytes of RAM, so that's 4 terabytes more or less. That's a T, not a G, so it gives you a bit of an idea of just how much possibility there is simply to scale up, where you don't have any other complexity around, you just kind of scale the thing up. And the good thing is, if you hit the limits for that, you can get more. You're not limited to one instance, then you have multiple instances there, so you actually have lots and lots of possibilities to scale to what a lot of companies would probably consider infinity compared to their own needs. So you actually have a lot of nice things available there. But then you can say, well, you know what, Axel, all nice and well, but I've got these individual services and they've got different needs, and this guy needs a lot of memory and that one doesn't, and this one needs CPU. How do you actually deal with those things? So how do we scale those individual services asymmetrically? Well, again, we have a spectrum of possibilities. The first one would be something on, to use a JVM term, to use an executor service where you have different capacity per module. So this is really just a way to assign thread pools to that will then perform work for a specific module or service out there. And so in this case here, for example, for the payment service, we could assign 10 threads that would always be running, and we would have 25 at our disposal for the invoicing, for example. You can just size this however you want, but this is a nice way to kind of allocate from, let's say, your 128 virtual CPUs, that you allocate this chunk of processing power over here and that chunk over there, and then you can kind of divide those up in an asymmetric way amongst your different modules or services. So this is a nice first option at our disposal. If that, for some reason, doesn't work well, or we hit certain limits there, the next option up is to look at queuing. But again, we don't need to look at separate technology just yet. Relational databases are actually quite a nice Swiss Army knife for those things. So we can have a queue implemented in the database as a table, and different number of consumers that will then compete to be able to get messages from that queue and to read there. So it's actually something that is quite efficient with modern databases. So if this were to be our queue with our individual messages with some kind of ID, and in this case a JSON payload, then we would be able to insert into that queue. I'm using Postgres syntax here, but it's as you'll see later, it's all kind of the same for different databases. So we insert a new message, would automatically get a new ID with some kind of auto increment column. And then once you want to get to that message, there's a nice thing here where you can actually perform within. You open a transaction, and then within that transaction you issue a delete statement where you select the message that you actually want to process. So you can do this with your standard select, but you add for update skip block. So this is the Postgres clause with MySQL 8 is also adding support for this. And this basically allows you to do a select for update, but instead of blocking on the first record until a lock gets released, if somebody else is accessing that record, it will just skip to the next one. Is it locked? Then I skip to the next one. Is it free? Then I grab it. And once it's grabbed, it's being returned to the application. So it returns the result set to the application. The application can then process it. If it's happy with the processing, it commits their transaction and the record gets deleted. If there's some kind of error, roll back and the record is still there. So nice and easy thing, very compact, that works with the relational database just fine. No need to adopt a separate technology, and this can take you a long way already. If that doesn't work anymore because you hit certain kinds of limits, certain kinds of contention there, again, we can move one level up and we go to a dedicated queuing system that offers very high performance, where you can again have a variable number of consumers for different queues based on the amount of resources that you want to allocate there. Now, microservices, large choice of technology where I can do certain things in Node and in Go and then on the JVM, for example. So it's kind of unrivaled for that. It's a clear advantage. But if you kind of look at least the JVM platform in terms of languages, you do actually have quite a large choice available. So you could be doing things in Java or in Kotlin or in Scala or in Ruby, in JRuby, and there's half a dozen more that you can use there. So it already allows for a lot of freedom when you have specific modules that would be better suited for a specific language there. You can already do a lot of things there, and then you integrate via a clean API, and you can have at least a somewhat a form of language independence there that gets reasonably close to what you would be able to get with microservices. Now, a bit of a shameless plug now, because if you actually have your Majestic Modular Monolith or your microservices, you actually want to be able to deploy them somewhere. So this is where I'm going to shamelessly advertise for the stuff that we do. So if you deploy on AWS, we have a fantastic solution for you there called BoxViews. It's basically continuous deployment as a service for what you have there. With just one command, you can deploy your app, and it'll set it up so that it can auto-scale and will automatically provision all the resources that you need. We'll set up centralized logging. We'll do all kinds of things for you so that you really can focus on development and you don't have to deal with the operations part. We make sure that this is all deployed as part of immutable infrastructure and infrastructure as code, so that you've got a nice overview of your infrastructure that you can check into version control and version it there and update it, and it will automatically propagate those changes for you. We've got minimal images with a dynamically generated, very small Linux-based operating system, which is just basically a kernel, an init script in your application, so that you've got a very small attack surface there, which is a nice thing to have these days, and we offer zero downtime blue-green deployment. So that's a bit what we do with BoxViews. On the Flyway side, we offer database schema evolution. So this is basically a way to evolve your relational database schemas across your different environments, so that you can then reliably evolve the structure of your database in dev, in testing prod, so that the expectations that your application or your modules or your services have are fulfilled in all of those environments. We like to say that you can do it with pleasure and plain SQL if you use Flyway. So we support the vast majority of the relational database systems out there that are somewhat popular. Flyway's had about 4.3 million downloads last year, so it's very widespread. It's been designed from the start for continuous delivery. There is an open source Apache 2 licensed community edition, and since Flyway 5.0, we also offer commercial pro and enterprise editions, including support and features for advanced users. And we pride ourselves that it's very highly focused as a tool, so it really solves one problem and solves it well and makes it very easy to get started. So we've got all kinds of getting started guides for you where you should be up and running in less than 5 minutes. So if we summarize everything that we've discussed today, our Majestic Modular Monoliths are really, for a lot of organizations, the best, most pragmatic choice, so that you can combine the simplicity of monoliths with a lot of the structure and focus advantages of microservices. So this is really something that you should consider based on the kind of problem domain that you have, the kind of the size of your company, the resources that you have at disposal, and looking at those ranges that we talked about of options that you have available for the different problems, and kind of pick where you would fit the best on there. Or if we were to summarize it in one sentence, it would be go modular and make your monolith majestic again. Thank you very much. Any questions? Yes.
So,
go for it. Yeah.
One of the major advantages of, well, at least in my opinion, is of microservices also that you have independent teams that are able to not only develop their stuff in their own speed, but also are able to deploy it, and if there is a problem, redeploy it or fix it and redeploy it. How can you cope with that scenario in a monolith?
So we'll say how can you cope with it in a Majestic Modular Monolith, yes. So division of labor, again, if you modularize your code base, whether we're talking about Maven modules or modules at the build tool level, or whether you actually rip things out and have them as separate libraries, these are nice things where then teams can work in isolation to reduce the impact on external teams when you actually make a change, and you can have a nice clear API to the outside world that is very stable, and you can iterate within that, and if you need to change it, you will probably have an impact on other teams, just like when you would change the API of your microservice. you then have some kind of communication work and probably some kind of coordination that needs to happen there. Now, in terms of being able to deploy that independently, again, based on how it's done, if it is an issue that there is a team that, for example, produces output that is of varying quality, let's say it diplomatically, then you can extract those things as in a separate repository, version it separately, and in the main application, pull in a specific version of that dependency, deploy, doesn't work, roll back that version, rebuild, and deploy again. Or simply deploy the old version of what you already had built before, and that would work again. At the end of the day, today it's usually some kind of automated process that will do that, so you'll have some kind of commit, and then it will kind of do those things, and then you can probably even integrate it with some kind of smoke tests, or what we do with box views as well. If the health checks don't come up correctly, we automatically roll it back, and your old version is back up there. So you can have those tools at your disposal there to help you with that. Anybody else? Yes.
Hi. Thanks for the great talk. So let's say we are following these practices in the code, but we still have database relations and joins and associations on the entity level across these domains. So what would be your hints or best practices to migrate away from these relations? So
I think that the same things mentioned previously apply. So the first thing would be start identifying which kind of areas are highly cohesive, where you have some kind of functionality that fits nicely together, that you can start carving out. And then you have the exercise to be performed both on the code and on the database side, where you have to probably in small steps start to kind of remove some of those joins, rewrite some of the code or some of the queries that have been using that, untangling some of the classes on the code side as well, to kind of separate these things so that you don't call, let's say, the implementation of something else, but you then put a nice API in front. And so I would say the same thing that you would normally do, refactor in small steps. You kind of know where you want to head, so that's good. Have a common vision, and then gradually work towards that vision, one join at a time, let's say. Anybody else? Yes.
Just want to see me run.
So the next one is down here.
I think the reason why microservices are popular is because of flexibility, agility, and I think the major difference is if I have microservices, I can version runtime. That means I can make a recovery on a partitional functionality, whereas in a monolith, I can only fall back to the latest version of the monolith. So it depends on how many changes are in the monolith. That means, like in a microservice, I can say, okay, let's fall back payment because it bombs. Or I can run even two versions of payment at the same time. That means if that one payment which is new, I only give 10% of traffic, and you know all these games you can play. I think with a monolith, this is not possible.
So I would say this is the first thing here really is that we're talking about some kind of versioning issue, right? If this is a need that you have to be able to roll back individual parts of your system, then you can then move those parts to separate repositories, version them separately, just like you would have individual library versions that you would put in, and you don't necessarily pull in the source code of your libraries. You have a well-defined version 5.2, and that doesn't work, and then you go back to 5.1 and deploy that. So that's one way you can address that. Now, in terms of kind of being able to run multiple versions at the same time, there's again different possibilities, because one of the options is something like canary deployments, which you described, or you could also have some kind of logical switch built into the application, where you would say, for example, that you attach a specific flag to user accounts that would say this user gets the new, let's say the the new registration page or the new invoicing page, and that one gets the old one. And then in that, when you're kind of serving those things, you read the flag and you go to one direction or the other, and you direct to one logic or the other, besides some kind of behind some kind of if statement. So this is really the whole feature flags, feature toggles type of things which you can implement in code as well to be able to achieve those things. So that's definitely possible there. The means are slightly different, but you can achieve the same result. Yes, very good. In the front, run, Christian, run. Yeah, you get it afterwards. It will be boring.
Yeah, thank you also for your talk. And when I read about the title, so Modular and Monolith, the OSGI came to my mind, and it turned out to me, it seems it was a dead end. So no one is using this anymore. What is your opinion on the OSGI framework and the approach which was connected with that?
So I've actually had the pleasure to work on an OSGI project a few years ago, so I know firsthand what kind of...
so you removed it, by the way, from our code completely.
Pardon?
We removed that OSGI.
Okay, so you removed the OSGI, yes. So for me, I think OSGI brought a number of things to the table. On the one hand, it brought the modularity with the clear versions for the bundles and those things, and then they had the kind of hot reloading at runtime and that kind of hot patching there. And I think that's where this part. I think that idea was a very bad one in my opinion, because then you get untested constellations at runtime. You test on your production environment where you have different versions of your modules that you maybe had in that exact constellation as you were running your tests that you see for the first time in production. So I thought that was a very poor design choice that they made there. Now, in terms of modularity and actually being able to have some kind of built-on dependencies, I thought those things were good at. But in my opinion, you can achieve 98% of the benefits of OSGI with those kind of Maven modules without needing the runtime complexity. And it became also a bit of a mess with the class loaders and the fragments and all the rest associated with it. So good riddance. I'm happy it's gone.
Okay.
Well, that's boring. You left now. I wanted you to run on. Okay. So, anybody else?
Everywhere. Oh.
Okay. Well, no problem. I'm gonna be around here. So if you have any more questions here, just come on down. I've got. If you want to pick your laptops, I've got some Flyway and Boxview stickers to hand out. Otherwise, thank you very, very much for coming in.
We finished the pizza, well done there. I see there is beer left, so stick around for some conversations and drink up the beer. And besides that, have a nice evening. Glad you were all here. Thanks.